So when you dilate something, all you're doing, and we've done this before, is you're enlarging it or making it smaller, and it creates a similar figure. So again, in this case, let's imagine that this line here is maybe it's 2 centimeters, and on our bigger shape, it is 4 centimeters. What's happened is this has been dilated by 2, right? It's been made larger by 2. So I just want to do one quick example before we go into something here. And that is on, what page was that? Dilation. It's quite a bit down. It's quite a bit farther down. Here we go, on page 234. It has the solution below it. Try not to refer to it, but just on page 234. Super, super quick. We're only going to do this, and then we're going to do one together, and then we'll carry on forward. Okay, so in this case, we have a rectangle below. We can see that it's 4 centimeters long and 2 centimeters wide. So it wants to dilate this rectangle by a scale factor of 2. So what that means is we're taking this rectangle and you're going to make it twice as big by a scale factor of 2 times everything by 2. So now instead of, I'll just draw it here. You don't need to draw this. So now what it would actually be is it would be a total of 4 centimeters tall, because 2 times 2 is 4, and 8 centimeters long, because 4 times 2 is 8. So this would be your new shape. So when you scale it by a number bigger than 1, it's going to get bigger, right? We've looked at this before with ratios. Now, when you dilate these rectangles, though, by a number smaller than 1, what's going to happen to it? It's going to shrink. Yeah, that's absolutely right. So now 2 times 0.5, you're going to have it's going to be 1 centimeter tall and 2 centimeters long. So we've done this before, so we don't need too much of a refresher on it. Whatever number you have there, times it by that. That's really what it boils down to. So that seems simple enough here. Now, where it gets a little bit trickier is, now I'm not going to tell you what this scale factor is. Now I want you to figure out how to find that. So what happened in this case was, okay, I now have a rectangle that's 14 centimeters wide and 7 centimeters tall. So what they did here was, okay, so 14 centimeters wide. This one over here is 2 centimeters wide. Wide by, oh, this one is yeah, this one, they did a straight up error here. This should be, this word here should be just cross out wide, put in long. They did an error. So now I'm going from 4 centimeters long to 14 centimeters long. So that means it got times by some number to get there. That's what the scale factor is, right? It's what you times it by. So sometimes it's obvious, sometimes it's not so obvious. If this is really hard numbers, maybe there's a decimal in there, you wouldn't know. How could you find that? Well, just figure out how many times 4 goes into 14, right? 14 divided by 4? 3.5. So I know that this is 3.5 here. So the scale factor in this case is 3.5. For question C.
What page is this again?
This is on page 234. Okay. So we're going to do one more together, and then we're going to go into some creative modes here. So everyone has that. Okay, scrolling down just to the next. Yeah, you can see an example down here. B is the smaller one, A is the bigger one. Okay. So when you have these first examples here, like A and B, hey, this is a scale factor. What's it going to be? You just multiply it, right? So you're going to obviously get stuff that's a little bit more difficult than that requires some more logic and problem solving. So question 16 here, for example, is we have a triangle that has these side lengths. They want to know what the length of the triangle will be if it goes through these scale factors. So I'm just going to draw a super quick table. We're not going to spend a lot of time on this, but basically, going to do a nice little table here. So I have my side lengths. So I'm just going to put side 1, S1, side 2, S2, side 3, S3. I have my original. I'm going to put the OG. I have my original. I have my scale factor of 7, and I have my scale factor of 0.4. The OG. So for my OG sides, I had 5.2 centimeters. I had 6.4 centimeters. What? That how is OG sexy? What? That makes no sense. So all I'm going to do is I'm going to take my original sides. I'm going to times it by the scale factor. So in this case, I'm going to times it by each of those by 7, right? So 5.2 times 7. You'll end up with 36.4. That's it. Not times by this, it's just 60, it's just 36.4. You take 5.2 times by 7. The OG. Oh, yes. So that's exactly, I'll just do the sevens first. So I take 6.4 times that by 7. 44.8. Take 9.6 times that one by 7. Again, you could do this in your head if you wanted. Feel free to just use a calculator too. You have those at your disposal. 67.2. So your shape is 7 times larger, right? But when you have a scale factor of 0.4, it's going to get smaller. So now what I do is I take my same numbers, my original numbers, 5.2, times that by 0.4. I get 2.08. I'm just going to move my calculator to my screen just so it's not blocking your guys's. Same thing. I'm going to take my 6.4 times that by 0.4 as well. 2.08, yes. Okay, so I multiplied all my stuff. I end up with 3.84 as my last figure here. Perfect. So again, when they give you the scale factor, it works out okay. When they give you the scale factor, times it by it, you're done. That's it. It's step 1 and done. 3.84, yes. Yeah. Okay. So I just wanted to give us an idea there of the scale factor, or we'll come back to this in a bit. We'll come back to dilation in a bit. That's making it bigger or smaller. I want to take a step back from the workbook now for today, at least as much as possible. We'll do more like textbook type problems that you'll see on your exam. We'll do those later. But for now, what I really want us to do is I really want us to get a really good understanding of these 4 different things. Oh, give us a second. Yeah, we get to paint. I'm not sure. Where are they going? Oh, okay. Okay, so you might have seen something like this, usually in bathrooms, but it can be on other stuff as well. These are bathroom floor patterns. It's not very big on here, but so what happens is they take tiles, you get enough of them, you put them together, it turns into a pattern. You see this in lots of houses, on the outsides of them. You see them in bathrooms a lot. Sometimes you see them in like kitchens and stuff. But so what we're ultimately going to do today is we're going to design one of these, and you're going to be eventually model in a bathroom is what's going to happen here. I just have a couple different examples here that I just wanted to kind of show, but these are all different. These are all different patterns that you can see here. These are all tiles that you can see in like bathrooms, for example. And you can see that they've taken simple shapes and they're able to turn them into some type of a design, some type of pattern that happens here. And usually it's just very small tiles. And when you put them together, they form a really cool pattern. Like I think it was, yeah, this one. This was one of my favorite ones, for example. All they did here was they took diamonds and they were able to make that. It's one shape, it's diamonds. That's it. So it's able to look pretty cool. And there's like loads of these all over the internet. Some of them are complex, some of them are really simple. Again, like this one's just two different shapes and that's all they did, but it's just two small tiles. They just put them together and they form some type of a pattern. So that's what we're ultimately going to do today. So like I said, this is taking place of those exam style questions because this is the type of stuff you could be expected to do. If you're ever planning to do like any type of a home renovation or you're doing any type of a design for like work, this is something you'd actually need to factor in and consider. So we have what we're going to do is we're going to do a bathroom tile project. I'll upload this onto the LMS right away. In fact, let me just hand out this to the people here really quick.
Well, do we get two each?
Sorry? Of the canvases?
I see like, I see.
Maybe. I'll think about that. Okay, so everyone has one of these here. So what you're ultimately going to be doing here is you're going to be doing a tile insert for a bathroom renovation. Sorry? No, but I wish I did want to actually take pictures of your guys' work after because I don't have an exemplar to show off for this one, to be honest with you. So it'd be really helpful if I had some previous examples to show. But what you're ultimately going to be doing is you're going to be making a design that's going to meet these specifications. So ultimately, it's going to cover an area of 2 feet by 2 feet. That's 60 centimeters by 60 centimeters. We'll go into details of how you get this stuff. Like, don't worry if you're like looking at this like I don't know how to do that. That's okay. It's going to contain 2 different geometric shapes. So what's some examples of geometric shapes? Triangle. Square. Yeah, square, rectangle, parallelogram, circle. All of those things are different geometric shapes. It's just shapes, just shapes. And as you saw, you can take simple shapes, you can make them into really cool designs. Like look at this one over here. I know it's very hard to see. Let me zoom in. But look at this one here. This one on the wall, the blue stuff. It's just squares and triangles, but they also use color as well. So you can also incorporate that into it, right? If you remember that really cool diamond one I showed you.
Just like any kind of pattern, right? It doesn't have to be geometric.
It has to be a geometric pattern. So like this one right here, just diamonds is all they did. Now, I would count this as part of it. I would count this as 2 shapes because you're using different types of color for it, and it's turned into a good design. This would count, okay? So what you're going to do is you're going to be trying to make, you're going to try and use at least 2 different shapes, and it's going to cover this much of an area, and that area can repeat, right? All these patterns I've shown you, that's just like something like this. It's just something like this big. And I guess for those of you online, you can't see, like, you know, maybe like a foot by a foot, and they just place it. They keep going. It's like a brick, right? You put enough bricks in a pattern, it makes a cool design. That's exactly what's happening here. So you want to try and use at least 2 colors. You can do more, and you're going to try and use transformations with it. Those are the 4 things that we've been learning about, right? Like rotations, enlargements, making it smaller, reflecting the image. That's what all of these things are doing. So you can make them simple, you can make them complex. That's okay. Get creative with it. Have fun with it. That's the whole point of it. So what you're going to do is, there's a little bit of research you'll have to do here. Whenever you're doing a home renovation, you're doing a home project, you have to do some research. What kind of tiles are used, right? What, like, does anyone know, like, what kind of tiles could you use? Does anyone even know? Glass, ceramic, porcelain. Yeah, there's different materials. Yeah. Marble, yeah, marble tiles exist. Yeah. Yeah. So there's different types of tiles well, tiles can break. Yeah. They all have strengths and weaknesses. When I was doing my floor, I had to weigh, do I want to do rug, laminate, or vinyl? I chose vinyl because, hey, it's a basement. It gets water in it sometimes. That's more water resistant. You want to look at what sizes are available. You can make your tile however big you want. If you want to do a tile that is like 1 centimeter by 1, maybe not once, but 1 inch by 1 inch, go for it. If you want to do a big tile that's 2 feet by 2 feet, go for it. You want to do something in between, that's cool too. You want to know about what colors, you want to think about what shapes. You have to look at how much these tiles cost, just a rough estimate. You're not looking for a tile that someone else has made to use. You're just doing some research on how much it would cost for your tile to be out. Where could you look up to see how much bathroom tiles cost? Yeah, Home Hardware, Rona, Google. Yeah, all of those work. I don't think Canadian Tire, but hardware shops, PV Mart, stuff like that. So what you're going to be doing is you're going to be designing a tile. You can either use that canvas, that's the stuff that we're going to be painting on later, or you could do it on just like grid paper if you want. That's that graphene paper that we've used. Again, for those of you online, that's what you might have to do. You can use paint, you can use pencil crayons, you could use something on the internet if you wanted to. That's okay. Sorry? Right now, just 1. Sometimes more. There's a couple different things here. You want to have at least 2 different colors. And then I just want you to show different transformations that you've done with your tile. You only need to incorporate 2 into your design, but I want you to show me that you can do 3 of them, okay? That's where you have to pick 3 of those 4 different options, right? Reflection, dilation, rotation, stuff like that. So ultimately, what your end thing's going to look like is it's going to show some of your research. It's going to show the drawings that you've done or the paintings or something. I recommend doing a drawing on the grid paper first, right? I'll get to that. You want to have an explanation of the transformations used in your design, and you want to know the quantity and price of those types of tiles. So it's not just going to be, I've designed a tile. You're actually going to be pricing out how much it would cost to do a wall. And you have 2 options for that.
So why don't we get Mark for the morning consultation? And for pricing.
Because, well, not everyone here's in the morning class. I would have otherwise. I would have done that otherwise.
Well, it's not fair. I'm just kidding.
Life's not fair. So, kinda. So, you, like I said, you're going to actually try and price out a real bathroom wall, not all the walls, a single wall. A floor is also acceptable. So, well, which wall are you going to do? Yeah, you have options. You can either do your wall at home, your like your own bathroom wall. You'd have to measure it this weekend sometime. You could do everything except measure it.
seriously want to measure the bathroom.
A wall on it, yeah. You can do an estimate, like a rough
Okay,
estimate.
so it's not-
That, and, or you could do this bathroom, yes. Yeah,
I'll come crazy.
so. So just to kind of like reiterate here, you're designing a tile, you're doing some of these transformations on them. You want to try and use two shapes, at least two colors. And you're eventually going to do some research on how much that would cost and what it would look like. And so before you guys instantly start going, this is what I want my tile to look like, because that's what you're painting, what your actual tile would look like. What I want you to think about is what should it look like? Does it work in my rotations? My reflections and stuff like that. What would it look like if I took a bunch of these and put them beside each other? So what you're probably going to have to do for a bit is you're going to have to experiment a bit with just some pen on paper. It's like, what would this look like if I take this single tile and I put a bunch of them together, for example? Is there a pattern that kind of shows up? So that's what we're going to be doing. This is not printed out for those of you in person. This is on the document that is going to be uploaded right after this. But what it's kind of assessed on is, I won't go over each of them, but it's assessed on your understanding of those concepts, those four concepts we've been going over the last 2 days, of all these different things here. So basically your research, your problem solving skills, and then just that your plans are really well documented and communicated. If you were doing this for some type of like a business or a client, you would have to have all that stuff, for example. I wish I had like an exemplar, like an example one to show you. I don't. I apologize for that, but I don't. I just don't have one. Is there any questions on this project at this moment? It's meant to be hard. So you're doing this and sorry? Yeah, I mean, something that isn't like, hey, here's more test type questions, mix it up a little bit. Yeah. So like, again, you're thinking really big picture here. You could make it simple. You could make it complex, whatever works for you. So what I'm going to do is I'll cut you guys loose. My recommendation though, is take some graph paper. I have some there. I'll put more there. And just experiment a little bit. Lindsay, for you, I don't know if you have a printer or not. If you do, you could use grid paper. I could send you it, where you could print that off. If you don't, that's okay. You can just kind of like freehand it or something too. That's okay too. You can even use like Microsoft Paint or anything. Yeah, I will cut you guys loose then. I'll give you as much time as possible. Oh, Jasmine, your question. When is this due? It's a very short unit. I'm thinking it will be due by Wednesday, but you get today in its entirety to work on it. Maybe some of Monday, I'll have to see. Because remember, we only have a week and a half left before the departmental, so I don't want to spend too much time on it. Yeah, we're in the end game. Okay, so I'll let you guys go then. To start out with that, come up with like a sample design. Yeah, come up with a sample design on graph paper, and then just start doing some of that math with it. Start putting them side by side, rotating them. And then when you think you have a good design, you could then take the canvas or any other thing you want and make a official tile that would be used.
You only make one tile.